Let's say a few words about app development. As a reminder, purpose of apps is the following. So apps are the main mechanism to extend and customize Supervisely functionality. And from the user perspective, apps should have the following properties. So they have to be functional enough. They have to have graphical user interface, complex visualization and interactivity. And even most importantly, probably, it should be easier for Python developers and data scientists to develop Supervisely apps. So ideally, Python developers write their code the way they used to do it. Their app interacts with Supervisely via Python SDK. Layout for graphical user interface is defined by simple HTML, and user interface components like tables, charts, buttons are controlled via Python objects, which we call widgets. And ideally, all the code base, or the majority of code base, is on the Python side, while HTML is just simple or even trivial. So next I will show you an example of interactive object distribution app that is quite functional, but also will take a look how it looks from user perspective and from developer perspective. Colleagues, I would like to illustrate app development process a bit, and for that I will use one specific app called from reports and stats category called interactive object distribution. And I will apply this app to process the labeled images from Pascal Vogt dataset. So let me first show what the app is doing, and then I will show you the source code of this app. So I will run a very specific version of the app for the reasons that I will explain shortly. Let me just run this app first. So the app is ready. Let me open it. So first the app asks me to click this calculate stats button, and it will process around a little less than 3000 images, labeled images from Pascal Vogt dataset, and it will show me like basic overview. So what we see here is the names of the classes that are specified for this project, and on the columns here we see the number of objects of specific classes. So what the app allows us to do here, say if we take a person class and navigate over this cell, it will show us the references to 507 images that contains exactly one person. And we see that there are less images with two persons, and maybe I will navigate to this cell that cell that contains 5 persons, and we have 25 images that satisfy this condition. So if I click on this cell, what I will see the references to these images. I can open them in labeling interface if I want, or I can just click preview button to see the images themselves, and I should expect to see here 5 persons. So that's exactly what we see here, and I can navigate to other images here and click on them as well to inspect that it's the case. And that might be quite a convenient way to, let me also check the last one. So yeah, we also see here that probably there are more persons in the bus, that I think that only 5 of these persons are labeled on this image. Okay, and what this app allows us to do in general is to explore a bit our data sets. For example, here we see outliers, like in this cell. So we have only one image that contains quite a number of bottles, and say this image that contains unusual number of objects of class ship. Again, we can click and take a look at the image that corresponds to specific condition. Okay, so let me quickly show this app from the source code perspective. If I click on this button and click on GitHub page, I will find myself on the GitHub page of of a specific app. And in this example, I used very specific version of this app. It was this version. Okay, and this version consists of includes Python code, and it also includes HTML file. And in the latest version of this app, we completely get rid of HTML file to make the development process more friendly for Python developers. But in this case, the HTML file is relatively small, and we see that there is references to the widgets, like this chart reference. So if I open right now Python file, files, there are just two of them. The stats just do some pre-processing. It's also a relatively small file here, and there is a main py which actually implements the logic. And let's see if I search for this reference that I outlined in HTML, I will find these references in the Python file. So, for example, here we create a widget for this large table with number of objects, and here how we handle the clicks on this table. Also, it's like a relatively small file. And my point is the following. So, with relatively small number of Python code and HTML code, we may ensure quite rich functionality. Probably I should also mention that according to our experience, as apps becomes more and more complex, this HTML file grows, and we wanted to avoid that. We wanted the development process is convenient for Python developers, and in the latest version of apps there is no HTML file at all. So that's it for this live demo. See you later. So this app contains 188 lines of code. So that's kind of a good ROI, return on investment, because with just 189 lines of code, we get very interesting functionality. And this app use some widgets from Supervisely library, like Supervisely table and gallery, and the widgets from Apex chart library. So if we decompose a bit Supervisely widgets, we will see that there are visualization widgets, input and control widgets, layout widgets, and other specific widgets available. We do have wrappers around other popular JS libraries. And here is an example how easy it might be to create your own widget. Last thing to show in this section is live demo. See you.